so acceleration, the equation for acceleration is A is equal to the change in velocity. So that triangle indicates change, meaning the Greek letter delta, over the divided by the time taken. Okay, so this area is acceleration. And the only thing you really need to know from that, as well as that, is the unit for acceleration. So the unit of acceleration is meters per second squared. Now, make sure you do know this one, because there's usually a marking point for that unit in the exam. So know the equation and know the unit. Okay, everything else is just the steps using the equation. Step 1, write the equation out. Step 2, substitute in the numbers for the symbols. And step 3, do the actual calculation, not forgetting the unit. Okay, and that's pretty much all there is to doing that one. I won't write down the v squared minus u squared equals 2s equation, because that one is actually given to you. So it's not one that you need to recall. Okay, just be aware that it is there. Okay, so the next thing we're going to look at is distance time graphs. Sorry, no, we're not. We're going to look at velocity time graphs. So I'll call this a VT graph for short. So we're writing out the whole word. So VT graphs, or velocity time graphs, very similar and very easy to confuse with your distance time graphs. The only difference being that's velocity against time rather than distance against time. So draw your graph like before. Remember, velocity is the same thing as speed. So velocity time graph, and we might have, just like our distance time graph, a gradient. And what does the gradient equal? So I'll draw 2 gradients and a horizontal section as well. I'll label those 1, 2, and 3. Okay. And if we then label those parts 1, 2, and 3, what do each bit mean? So the part that's 1 is a constant acceleration, because we're changing the speed at a constant rate, and that's what acceleration is, changing the speed. So this one is a higher constant acceleration. So high constant acceleration. And part 2, that is a lower or low constant acceleration. So the gradient on the distance time graph represents acceleration. The horizontal section, point 3, then, here we're going across a straight line across to a specific velocity. So this one is constant speed or constant velocity. Okay, I'll put our speed, because remember, speed and velocity is the same thing. Velocity is just speed in a straight line. And then, just like with the distance time graph, what does the gradient show us? The gradient shows us acceleration. So if I label a point, let's label this point here as the point xy. So it has the coordinates xy. So the gradient equals the acceleration. So basically, it is the y value divided by the x value will give you the gradient. So that point there, if it's from 0, 0, if you're doing the higher, you might be asked to do the difference between 2 points. So that, just like we've done before, it's the change in the y value over the change in the x value. So the gradient on a velocity time graph is acceleration. So the y value divided by the x value. Okay, the next thing that led on to was terminal velocity. Okay, now this bit is probably the hardest bit. And quite a popular question because it links in with so many things such as forces. So on this one, what we're going to show is terminal velocity is when something is in free fall. That means just falling through the air, nothing around it. Okay, so only gravity pulling it down. So the only forces acting are weight downwards and drag or air resistance upwards. If we look at the example to explain this of a skydiver. So what I've got here is an airplane. Again, you could do an apple falling out of a tree or anything falling basically. So there's represent my airplane. And from the airplane, our skydiver has just jumped out. I haven't got the parachute open. We're not looking at the parachute at all. So there they are. So the starting position for the person is they've literally left the plane, so they're not falling just yet. So we're looking at it just before they actually fall. Okay, so what we have, how do we calculate the forces? What we've got is the weight. So W is the weight. The weight of the person is mass times gravity. So the weight of the person is acting downwards. Okay, and that is the only force on them. Okay, the instant they leave the plane, the only force acting on them is their weight. They're not moving, they haven't started falling yet, so their drag is equal to 0. So basically the drag is equal to 0 in this position because they're not falling yet. Then the resultant force, remember this is the sum of all the individual forces acting on the person. So in this case, the force acting on them is their weight, which is therefore equal to mg. And their acceleration, because there is a resultant force, they will have an acceleration. So we'll say the acceleration is greater than 0. So whatever it might be. So from this point, they will accelerate downwards. A few seconds later, the person is still falling. But now what is happening? We've got, because they're moving through the air, we've got some drag forces. We've got basically, as well as the weight, we've now got an upwards drag. Okay, are a little bit bigger. So there's two forces on them now. We've still got the weight, which is mg. We've now got the drag, which is not going to be equal to the weight yet, so it's less than mg at this point as they're falling. The resultant force, okay, is basically equal to the weight mg minus the drag, because they got the weight pulling down and got the air resistance up. So the total force is the weight minus the drag. At the moment, they're just starting to accelerate down. The air resistance is less than the weight. So therefore, they are still accelerating because they have a resultant force. So the acceleration, however, will be lower. They will not be accelerating as fast now because the resultant force is decreased. As it's falling, the person will increase their air resistance until the point where they have the air resistance is exactly equal to the weight. So the weight downwards is equal to the drag upwards. Okay, so in that situation, what we have is, again, the weight doesn't change. Weight's mg, drag, oops, spell drag properly, drag is equal to mg. The resultant force now is still the weight minus the drag, but since the drag is equal to the weight, that means the resultant force is now 0. And if you've got no resultant force, what is the acceleration? Oh, gone off the page there a bit. What is the acceleration? The acceleration is equal to 0. So at this point, we have terminal velocity. So this is terminal velocity here at that point. So the drag force is equal to the weight force. So therefore, they are no longer accelerating. They will now fall at a constant velocity, and that constant velocity is called the terminal velocity. Okay, now this section is for higher only. So if you've only on foundation, you can stop looking at the recording now, and we'll go back for higher to the velocity time graph. On our velocity time graph for higher only, if I split that up into two sections, so we've got the rectangle section here and this triangle section, if I call that 1 and call that 2, on this one, the area under a velocity time graph is equal to the distance traveled. So this is higher tier only. The area under a VT graph is equal to the distance traveled. Oops, squeeze there. Okay, so basically that section there, the yellow section, and the way you work it out is that's a triangle, so half the base times the height. This is a rectangle, so the base times the height. Okay, and lastly, on the terminal velocity, if you're doing the physics only, look at Appendix 8 specifically, because you'd have to look at from this point on when the parachute opens. So the skydiver obviously is not going to jump without parachute. When the parachute opens, the drag would increase. So therefore, there'd be a greater upward force. So they would have a negative acceleration. So they would slow down until the drag and the weight become equal again. Okay, and that is... So question card, write your question on one side, and then you read your question, think, right, on another piece of paper, you write down the answer someplace. You can check that by turning over. There's your equation. There's your unit, okay? Velocity time graphs. Right, so question. Again, you can pick your own questions. It doesn't have to be these ones. Draw a velocity time graph showing constant speed and constant acceleration, because that's what you need to know from your velocity time graph. How do you find the acceleration on the velocity time graph? Okay, try and answer the question. When you put your answer down, you can check. You've got your answer all pre-written. Right, have I written the answer correctly? Okay, so it's 1 is constant acceleration, 2 is constant speed. The gradient is the y value over the x value, and the gradient is acceleration. Okay, terminal velocity. Okay. Again, you could have describe what terminal velocity is. So in your own words, describe terminal velocity. Write it down, revise, check if you got your answer right. An object in free fall falls at constant velocity because the weight equals the drag or air resistance. For higher tier, describe how the resultant force changes for a skydiver. So at the start of the jump, the weight is greater than the drag. There is a resultant force, so there's an acceleration. As it falls, the drag increases, so the resultant force decreases, and the acceleration, therefore, decreases. When the weight is equal to the drag, we've got 0 resultant force, so there's 0 acceleration. And again, for a higher tier, your velocity time graph, okay? So you got to calculate the distance traveled from the graph. So how would you calculate the distance from a velocity time graph? Again, try and write your answer out, check what you've got. Distance traveled is the area under the graph. In this case, the area is the half the base times the height, or the area of a triangle. Okay, so you could use question cards, pre-prepared question cards, or the mind map.